Okay, this part picks up where I left off in the previous video, where we have what the estimated demand figures are based on these prices and these formulas over here. Now what we want to do is we want to compare each one of these estimated demand figures with what actually happened. So at a price of 450, we predicted 5174 in the linear model when the actual demand was 45. With the power model, we predicted 50.8 when the actual demand was 45, and with the exponential, we predicted 51.2 when the actual demand was 45. We need to translate that into a percentage, a mean absolute percentage error. So to do that, we use this formula right here. Take the absolute value of C4, which is the actual value, minus E19, which for the linear model was 51.74. and then express that as a percent of the actual value, 45. You'll notice that we've got a dollar sign in front of the C. This gives us what I will call a semi-absolute cell reference, meaning that if I copy this formula across like that, you can see that it keeps the C on this row. C4, we're always using this actual value. But if I take this formula and then copy it all the way down, it will update it so that now it's C5 for this row. See? C5 minus E20 divided by C5. C5, which is 103, minus C20, which is 104.3, divided by C5 again, which is this right here. That gives us an error of 1.87%. So that really saved us a lot of time in copying by using that partially absolute cell address, which I'll call a semi-absolute cell address. So the last thing we have to do is we have to figure out, on average, how accurate each one of these models were in predicting demand. So the average was 9.68 for those two, for that little column. So when we look at this one right here, this column, the power, this one is the most accurate because it has the lowest mean absolute percentage. So to review, what we did was we used scatter plots to get lines of best fit for the the price versus demand equation, and we put them here with their intercepts and slope and constant and exponents. Then we used the linear, power, and exponential equations, these here, in order to predict what these equations would say our demand would be if we used only these equations. Then what we did was we calculated the mean absolute percentage error of each of these estimates against their actual figure. Compared this against that, this against that, this against that, expressed it as a percentage to come up with all of these percentage errors, and then averaged them all down here. And then we picked the one that had the least percentage error. And that's the one, the equation, the power one, is the one we're going to use in order to make our estimates of what demand would be under different scenarios. And that'll be the subject of the next one, the next video, which will be on this profit model, which uses the power curve for estimating demand. And that will be the subject of the next video.